fourth graders. So today we're going to learn how to use our protractors to measure angles and to find, to figure out how to use what we know about angles and figure out the measurement of an angle either with or without the protractor. So if we look at our math book, okay, in our first page, we're talking all about angles and how they're measured in degrees. And we kind of already know that. We talked about this last week, where when we watch the Winter Olympics and the snowboarder does, you know, a circle turn, or what we call that a 360. Or when he turns around halfway, we call that a 180. So we already know that we're measuring our angles in degrees. But I want to think about how we can relate angles to circles. So when we look at this angle here, this angle has a measure of 1 degree, okay? So that means there is it's one tiny turn away from the 0, okay? This angle here is 5 of these put together. So it's 5 1-degree angles put together. So it measures 5 degrees, and we measure it here. Okay, we measure that one here. It doesn't look like there's much of a space, and there really isn't, but that's the point, is it's a teeny tiny little angle. Okay, and then this is 5 of those put together. So when we look at right angles, okay, and we think about it in terms of a circle, it is 1/4 of a circle, right? Or if we think about a clock, right? This would be 3 o'clock, right? That's 1/4, or 15 minutes past the hour. That's 1/4 of an hour, or 1/4 of a turn, okay? A straight angle is 180 degrees, and that's half of a circle, or half of a turn, okay? And then this 360 degrees, that's 1 full circle. Every circle is 360 degrees, and it is 1 full turn, okay? So 1/4 of a turn, a half of a turn, and a 1 full turn, okay? So then if we look at a protractor, this is where it gets fun. So before we put our protractors into use, you need to make sure that you're understanding that every protractor has numbers on the bottom and on the top, okay? So this one is 10 and 170, okay? That's because we can measure angles on either side of the protractor. When we set up our protractor to measure, we put the center of our protractor at the vertex, and the bottom line, and it doesn't matter which side it is, and I'll show you with number 1, the bottom line needs to line up with 0, okay? Now, if you're using this side, see, 0 is the bottom number. So we're gonna count up, because we're not starting at 180, okay? We're starting at 0, and we're gonna count up to where the line meets the other side of our protractor, whether that's down here, or in this case, it's at 90, okay? And there's only 190, because either way you go, it's gonna be 90 degrees, it doesn't matter. So that's how we use our protractors. We need to make sure that we are counting properly, and making sure that we're not thinking that this is 180, so this must be 90 more. It is 0, and we count up to 90, okay? So when we look at number 1, and we take our protractor, and we line it up, so we put the middle of our protractor with the vertex, and we line up, and if you don't have this little tool, that's okay. Just line up your line with 0, okay? That's pretty close, all right? Then I'm gonna take my little tool, or you can take your pencil and extend the line up to where the other side of the angle, the other endpoint, would intersect with the protractor. So for this angle, it meets at 70 degrees. Now it says 70 and it's hard for you to see, but it says 70 and then it says 110. But we know looking at this angle that it's an acute angle. It's less than 90 degrees. So I'm not going to say that this angle is 110 degrees because that wouldn't make any sense. We know for sure that this angle is less than 90 degrees. It's an acute angle. So for us to say that it was 110 degrees wouldn't make any sense. So we line it up again, make sure it's all straight, and that would be 70 degrees, okay? Then on number 2, they have the angle going the other way, which is totally fine. We just take the center of our protractor, line it up with the vertex, line this up with 0, and now we're using the top numbers, okay? Because this is not 180 degrees, this is 0. Then we take our little tool and line it up here, and we should get 110. Okay, 110 shares a spot with 70, but looking at this angle, our logical brain tells us it cannot be 70 because it's an obtuse angle. It's larger than 90 degrees. So it must be larger than 70. It's got to be the 110. So we just have to pay close attention to what side we're using and where our 0 is, whether it's the top or the bottom number. And again, using your logical brain on what makes the most sense, okay? So I'll post the other answers for these two, but I want you to think about before you measure what kind of an angle these two angles are, and then base your answer on what type of angle they are. This one is an acute angle, and this one is an obtuse angle. So this one will be less than 90 degrees, and this one will be more. And the same thing, even though it's turned differently, you just turn your protractor to however it needs to be and line it up. It doesn't matter that it's not facing the way that we want it to. So then looking at 5, 6, 7, and 8, we're going to sketch an angle using our protractor, or we can draw it out. Now for 5, we know that we can take this grid paper and make a perfect 90-degree angle without really using our protractor and without using you know, a ruler. We want to use a ruler for straight lines, but I'm going to switch to my iPad so that we can start writing on our book and taking notes that way. All right. So we did these ones, and we'll fill in these. This one was 70 degrees, and whenever we write it, we still need to include our units, and our degree measure looks like that. And then this one was 110 degrees, so it looks just like that. Just like if we were writing degrees for temperature. So then on number 5, we take it and we know that a 90-degree angle creates a perfect square. So we want to make sure that we have endpoints still and a vertex, still making sure that we're drawing good angles and taking good notes, but knowing that that's about as much as we need. Now for a 45-degree angle, it is half of a 90-degree angle. So you could do one of two things. You could either use your protractor and measure out a 45-degree angle and draw that out, or you can take a 90-degree angle and then cut that 90-degree angle in half. And because it's just a sketch, it does not have to be perfect, but you do want to make sure that if you're not using a protractor, that you're being pretty careful about drawing that line in half. Then a 180-degree angle is a straight angle, right? So we just draw a straight line. Oh, we want to label this one. Okay. And then 360-degree angle would be a full circle. Okay. Now, looking at 9, we want to know the right angles. So if we're looking at the right angles, we're going to be finding where we have these little boxes here. Okay, so these boxes should tell us without needing to use a protractor where our right angles are. So one of the 2 right angles would be angle MRB. And remember, we're careful to include that angle sign. Or the other one would be angle MRK. And then in the other figure, one of our right angles would be IAO. And also, if you look carefully, we have another right angle, UAO. So even though that UAO is split in half by ray AE, it still is a right angle using those 3 letters. Okay, so looking at our straight angles, remember a straight angle is 180 degrees. So we need 2 straight angles that are 2 straight lines, right? So we have angle, we'll call it BRK. And then in the other one, it's angle UAI. Okay. How much greater is the measure of angle KRB than the measure of angle IAO? So KRB is 180 degrees because it's a straight angle. Angle IAO is 90 degrees because it's a right angle. So again, we would do 180 degrees minus 90 degrees because we want to know the difference. Make sure you include a variable, x equals, and it's 90 degrees. Because 2 right angles makes a straight angle, and 2 right angles equals 180 degrees. Okay. Which angle appears to be a 45-degree angle? Now, we're not going to measure. We're going to use that logical brain that we've been thinking about. And remember, I told you that when you take a 90-degree angle and you cut it in half, you get 2 45-degree angles. So if you look at your figure, there is a 90-degree angle that's cut in half. Okay, angle UAO is cut in half by a ray AE. So it could be one of 2 angles, angle UAE or angle EAO. And finally, they ask, what is the measure of angle IAE? So we'll erase some of this. Angle IAE, so this purple angle, is 135 degrees. What is the measure of angle OAE? OAE, What is the measure of the angle UAE? UAE. So if we look at angle IAE, this is 130 degrees, or sorry, 135 degrees, okay? We need to take what we already know about these angle measures. So we know that angle IAO is 90 degrees, okay? And then we know that this angle is 180 degrees, angle UAI, okay? Now, we can do all kinds of subtraction and figuring out different kinds of things. What I want you to understand is that when you have angles that are added up like this, and you have for certain one, I'm gonna erase all this. You have for certain one straight angle, you know that it's 180 degrees, okay? You know that this angle here is 90 degrees. When you add this angle and this angle to 190 degrees, you'll get 180 degrees as long as your math is correct. So you can do the opposite, okay? And you can subtract and figure it out that way. But they give us the information that this angle is 135 degrees. So what I could do is I can take 135 and take that from 180. And you should get 45 degrees. And that's the angle measure of UAE. Now, if this is 90 degrees and this is 45 degrees, 90 plus 45 should equal something to equal, when you add up that final missing angle, you'll get 180 degrees. So if you take 45 plus 90, look, you get 135. Our missing angle here is 45 degrees because these two angles would be the same. Okay. So it's just really trying to figure out what the missing piece is. And we're used to doing problems like this all the time when we have word problems where we have two wholes, or two parts, and we know the whole, but we need to find the third part. So it's just figuring out the exact part that we're missing and how we're going to subtract or add to figure out that missing part. All right, finally, looking at angles in the real world. Now, when you go to the store or when you go to school or to a friend's house, there's a route that you can travel, and you can take different streets and different things like that. And there's more direct routes than others, just because of the way that maybe the streets are laid out or the way that you would travel. So streets, we'll see that streets are often laid out in a certain grid pattern, okay, especially in busy cities. So like if, for example, if you looked in downtown Reno, you would see that there's a very specific grid pattern that the streets are laid out in. So when we look at John's neighborhood, the east and west streets are named for presidents of the United States. So Lincoln, Washington, and Jefferson. The north and south streets are numbered: 1st, 2nd, 3rd, 4th, 5th, 6th. Okay. The avenues, these ones, have letters. Okay. John's house is on the corner of Lincoln and 1st. So here's John's house. What do the arrows left of the map tell you? Now, what's the point of those arrows? What do we call that? And if you're thinking that's a compass rose, you're correct. So the point is that it shows us the direction. So are we going to go north, south, east, or west? So it shows us direction. Okay. Now for 15, if John leaves his house and rides his bike south on First, what kind of an angle does he make for each turn in the route? So if he leaves his house and rides his bike south on First, what is the measure of each angle? So each angle here, okay? If he turns southeast on Avenue A, we want to know this angle, okay? When he reaches Washington, so he's still traveling down Avenue A. When he reaches Washington, he turns west. Okay, what's this angle? And then when he gets back to First, he turns south. So let me erase that and do it again. So if he leaves his house and he goes south and he turns southeast on Avenue A, right? What is this angle? So you'll need to use your protractor. Then when he reaches Washington, he turns west, so he goes back this way. And then when he reaches First, he turns south. So what angle is this one? And what angle is this one? Okay. And I'll give you a hint. You need to use your grid lines to tell you something about that angle with Washington and First. Okay. And then finally, John's cousin Cora leaves John's house and rides east to Lincoln Avenue, east on Lincoln Avenue to Avenue B. Draw the angle Cora makes if she turns southeast. So Cora leaves John's house and rides east. We'll erase John's bike marks. Cora leaves John's house and rides east on Lincoln. And then to Avenue B. So all the way down here. Okay. Then if she turns southeast on Avenue B, that would be this way. What is this angle here? So again, use your protractor to kind of help you figure out what that angle is. And think about, what do we know about that angle? Is it less than, equal to, or greater than a right angle? So then what should the measure be? Should it be more than 90 degrees or less than 90 degrees? So as usual, our answers will be up on our Google Classroom to help you double check your work. I'll see you later.